If our velocity function changes linearly from 0 to 8 centimeters per second over a time interval of 15 seconds, how can we find the distance corresponding to this motion for each of 3 5-second time intervals into which we divide the 15-second time interval? And I note here that this 5 seconds here should be 10 seconds, so let's somewhat sloppily make that change. Well, let's see. First we need to determine the velocity at each of these clock times. Of course we know at 15 seconds the velocity is 8 centimeters per second. We determined earlier that the velocity was changing at an average rate of approximately 0.53 centimeters per second per second. If we take that acceleration, that rate of change of velocity, and multiply it by our 5-second time interval, we obtain a velocity of 2.7 centimeters per second. If we multiply 10 seconds by that acceleration, of course, we get something which rounds off to 5.3 centimeters per second. So by using our knowledge of the slope of this graph, or the acceleration, or the rate at which velocity changes, we can easily determine these two velocities. We could also, knowing that this is a straight line, have done that by similar triangles. This triangle is similar to this. It's got 1/3 the width, so it'll have 1/3 the altitude. And this one will have 2/3 the altitude, having 2/3 the width. So there are several ways to do this. Now over each of these trapezoids that we obtain on the graph, as we've seen before, we can calculate the average altitude of the trapezoid, which corresponds to the average velocity, and multiply that by the width of the trapezoid. Now the width of the trapezoid is 5 seconds, representing a 5-second time interval. The altitude of this trapezoid turns out to be the average of 5.3 and 8 centimeters per second, or 6.7 centimeters per second. So we multiply the 6.7 centimeters per second by the 5 seconds, somewhat hidden by the circle I drew here, and we obtain 33.5 centimeters. We do a similar calculation for each of these two trapezoids, and we see that we move 6.7 centimeters during the first 5 seconds, 20 centimeters during the next 5 seconds, and 33.5 centimeters during the next 5 seconds.